Let's take a look at slope. So we have talked about direct variation, which just means that y and x are directly related, and the only thing that causes x to change is k. That's our constant of variation. We've also taken a look at partial variation. In partial variation, it looks something like this. This is where we have a constant that causes x to change. So again, that's m. And then we also have something that's called an initial value, which is b. And that just means that x is going to change time multiplied by however many m's there are. But no matter how many x's there are, we will always start with b. So for example, let's try a direct variation. So y equals kx. Let's say we had y equals 2x. Okay. So here's our x-axis and our y-axis. If this is 1, 2, 3, 4, 1, 2, 3, 4. Okay, so y equals 2x. Well, if x is 0, y is 0. If x is 1, then y is going to equal 2. And if x is 2, well, 2 times 2 is 4. So here you have a straight line, something like this. Okay, so that's direct variation, and you know it's direct variation because the line passes through the origin, passes through the coordinate 0, 0. Okay, now we could do a partial variation that might be very similar. We do y equals 2x plus 3. And all we would do is we would draw the very same line, but we would draw it starting 3 dots up. And let's take a look at why that might be. So we have 1, 2, 3, 4, 0, of course. 4, 5, 6, 7, 8. Go all the way up to 10. Okay, so x is 1. Let's substitute that in. 2 times 1 is 2 plus 3 is 5. So for 1, we have 5. If x is 2, let's substitute a 2 in there. 2 times 2 is 4 plus 3 is 7. And again, we have exactly the same line, except it started on y equals 3. So we took the very same line and we moved it up. We moved it up 1, 2, 3. Because it's 2x plus 3. That's easy to remember, right? It's plus 3, it just moves everything up 3. So it's pretty easy to remember. Now, in the format y equals mx plus b like this, we've looked at what b can do. So if b is plus 2, it's going to move this graph up 2. And it's going to look like this. If it's plus 4, it's going to move it up 4. If it's negative 2, it's going to move it down 2. It's going to be, but you'll notice something about all 4 of these lines is they're parallel. They're exactly as steep as each other. And that's where m comes in. M decides how steep the line will be. And how steep a line will be is slope. So slope is a measure of the steepness of a line. So you can pause for a second to write that down. Slope is a measure of the steepness of a line. So if the line, well, let's take a look at an example here. Let's actually find the slope of, let's draw a straight line here. Let's find the slope of this particular line. So what we're going to need to find the slope is we're going to need to take a look at 2 points on the line. To find the slope of a line or a line segment like this, you always need 2 points on the line. So let's pick this point and this point. Oops. This point here. So the first point well, the slope is how do we get from this point to that point? Well, slope is also known as rise over run. So the question is, how much does this line rise? Well, from this point to that point. Well, it goes up 1, 2, 3. So the rise is 3, and it goes over, it runs 1, 2, 3. So 3 over 3 is 1, so the slope, which is also known as m is 1. So that's a pretty easy one. Let's try another one. So what if we had one like this? Okay. So we need to find 2 points somewhere on this line. Well, this intersects neatly here, and here's another one. So there's 2 points. The rise over the run. So it goes up 1, 2, and it goes over 1, 2, 3, 4. 2 over 4. So the slope is going to be 1/2. Or you might even say 0.5. And that's all. So it's pretty easy to find the slope if you can just count how far up it goes or how far down it goes. There's a couple other ways to do this. First, let's take a look at a slightly different example. Sometimes you'll have a line like this. Pointing downwards. Well, it's actually exactly the same, the way that we solve this. So we find 2 points. So this looks like about a point here and here. Okay, now what is the rise here? Well, moving from left to right, the rise is actually going to be down 1, 2, 3, 4. So the rise is actually -4. It's going down. Remember, when we talk about rise over run, we're talking about moving to the right. Moving from left to right, it's gone down 4, and it's gone over 1, 2, 3, 4, 5, 6. The run is 6. So slope is equal to -2/3. M is equal to -2/3. So rise over run. The second way you can find slope is by using the coordinates that you're given. So perhaps someone will say, find the slope between 0, 1 and 3, 7. Well, there's a couple of ways that we can do this. Let's start with probably the most visual way, and we'll graph it. So 0, 1 is here, and 3, 7 is here. And we can draw the line just for sake of visualizing it. So now the question is, rise over run. How much does it rise? Well, it rises 1, 2, 3, 4, 5, 6. And it runs 1, 2, 3 over. So slope is equal to 2. Now, rather than graphing it, there's actually an even easier way to figure this out. You may have noticed that when we're going upwards and we're saying, what's the rise? We're going 1, 2, 3, 4, 5, 6. We're counting upwards, we're counting vertically. And that's just really, we're finding the difference between the y values. So here we have a y value of 1, and here we have a y value of 7. So how much, what's the difference between the y values? We can write it like this. So y value 2 minus y value 1 over, and we're going to do it for x values as well. So what that's going to equal is 7 minus 1. So we're really just saying, what's the difference between this y value and this y value? So the difference is between 7 and 1. It's 6, right? And the difference between the x values, between 3 and 0, is just going to be, well, it's just going to be 3. So that's 6 over 3, which of course we know will equal 2. So that's another way of doing it without even graphing it. The thing you need to remember is that when we set these up, we're going 7 minus 1. We can't now go 0 minus 3. We have to subtract from the same one. So you kind of have to decide which way you're going to go there. If that seems confusing to you, you might want to try it a few times graphing it before you try doing it without graphing it. Okay, so finally, the last thing for today, if you are given a line, perhaps it's direct or it's a partial variation, and you want to figure out what the m for it is. So let's draw one here. Okay, so remember, a partial variation like this is written as y equals mx plus b. We know that b is just how far above or below the origin the line has gone. So if this is going up 2, we know that it's going to be y equals mx plus 2. Let's pick a lighter color. Y equals mx plus 2. But what is m? Well, m is just a slope, right? So let's pick a couple points and find the slope. So we have a rise here of 1, 2, 3, 4. M equals 4 over, and a run of 1, 2, 3, 4, 5. So m equals 4 over 5, or you could also say 0.8. So that's what m equals. So really, the equation for this line is 4 over 5x plus 2. Now, we might be getting a little ahead of ourselves here, but really that's as simple as it is when you're looking at a linear relation. The b is just telling you how far above or below the origin is this line moving. And the m, the slope, is just telling you how steep is that line. And of course, determining how steep that is as simple as rise over run.